Okay, so today we're going to be looking at the assignment that talks about are they similar? So our task is determine using rotations, translations, reflections, and or dilations, so basically all of the transformations that we have, whether the two polygons below are similar. So the idea here is kind of like what we did in the previous section where we made one shape turn into another shape. We're going to do the same thing here. So it's similar because I'm using a smaller version of the same shape and I'm turning it into this bigger version over here. Okay? So they were nice enough as well to give us the intersection of the dark lines as the origin. So basically this is going to be the y-axis and this is going to be the x-axis, okay, with my origin in the middle. So that's going to help us kind of develop our work here, okay? So the idea is, again, try to make this shape, small shape, into the larger shape, okay? Now, I'm not going to do this one for you, but I did go ahead and make a kind of similar example. Okay, so the first thing that I see that I would probably try to tackle is I want to make the smaller shape into the same size as the big shape, because once I do that, then I can start doing like a rotation or translation and try, or a reflection, and try to make them match up. And I have a little more experience working with those, so let's try to do the dilation first. Okay, so the number one thing you want to do when you're doing a dilation is first we need to figure out the scale factor. Okay, and so the easiest way to do that is just find a measurement somewhere on the two shapes that you can correspond together. So for example, I have the bottom of my little T shape right here. Looks like it is 1 unit in length. Okay, and the bottom of the other T shape looks like it is 2 units in length. Okay, so I went from 1 in the small shape to 2 in the big shape, and hopefully shouldn't take you too long to figure out that I probably had to multiply that smaller one by 2. Okay, this 2 is going to represent my scale factor. Okay, and if I just do a quick check on some of these other ones, okay, so now let's look maybe at the top of the T. Okay, so the top of the small t is 3 units long. The top of the big T is 6 units long. So logic dictates 3 times 2 does give me 6. Okay, and so that tells me then again that the 2 must be my, go to my highlighter, must be my scale factor. Okay, so that's going to be what I'm multiplying by in this dilation. Okay, so our next step normally would be to take these measurements, take these points from the small shape and multiply them by 2 to get a larger version of the T that will match up with this bigger T down here, so then I can start doing my other transformations. Okay, now the one issue with that, okay, so let's just take one point. Okay, I'm going to take this corner point right here. So that point is going to be -7, because I go left 7, and then up 3. So -7, +3. Okay, well, if you take -7, +3, and you multiply it by 2, you get -14.6. Okay, and so basically, when we're faced with a problem like this, we have two options. We can either extend our graph, okay, but if you don't have graph paper at home or anything like that, that might be difficult to do, okay, and I don't trust my handwriting enough to extend my graph out 7 boxes to the left to get to -14, +6, okay? So instead, before I multiply by 2, I'm going to do a little translation to kind of shift this down to make my numbers a little bit easier. So what I'm going to do is I'm going to try to move this graph closer to the origin, okay? So what I'm going to do is I'm going to put this point down to right there, okay? So let's figure out what my translation, what my slide would be in order to do that. And as I do this, I'm going to change colors just to make it extra obvious. So on your guys' example, you're going to want to do the same, because if I go back to the original one that you guys are dealing with, well, you don't have a ton of room. And if you start trying to dilate this, okay, then you're going to end up, way out here, right? And you don't have enough room for your graph to extend that far. So make sure when you do this on your own, do the same thing I'm doing, because as we move it, as we translate it down, it's going to change the numbers into a way that will make the numbers smaller and will make the dilation fit on the graph. Okay? So let's go ahead and do that now. So before I can do that, though, I do have to do my translation. So we're going to put our point down here, and because it's a translation, the shape isn't going to change. So I'm just going to kind of recreate the same shape. So I went up one, just like I would go up one here. I'm going to go left 2, because I would go left 2 here. I'm going to go up 1, over 1, down 3, over 1, up 1, left 1. Okay, so the orange graph is now going to be the one that I actually do my dilation on. Okay, so what I'm going to do now is I'm going to take these points, okay, and I'm just going to multiply them by 2. Okay, so for example, this point is 0, 1. So that means when I multiply all those numbers by 2, I end up at 0, 2. Okay, up here. Now 0, 2 was also one of my points. When I multiply that by 2, though, I'm going to end up at 0, 4. Okay, and I'm going to repeat this process, and all it's going to do is double all of my values. Okay, just double everything that I'm dealing with. Okay, and again, all I'm doing is taking these coordinates and multiplying them by 2. 2, 4, 6, because my side that was 3 got extended to 6. This one's going to be the same as the one below it. Another 2. Oops, just missed. 2 there. 4 there. And down. Okay, so now I've gotten a shape that is just my other one. Now, you probably don't want to fully erase this, okay? But I'm just going to do that just to kind of unclutter my problem a little bit, to make it a little bit easier for you guys to see. Okay, now from here, I need to make this T turn down here, basically. I need it to orient a little bit differently, right? Right now, this T is upside down, and this T is on its side. So that means I need to do some sort of rotation or reflection to try and adjust it. Because if I just do another translation, it's not going to change the shape, right? My original T was on its side. My new T is also on its side, okay? So I would say, because I need to turn it, I probably want to do a rotation, okay? So what I'm going to do is I'm going to rotate this shape 90 degrees, okay? So remember, to do that, take your paper, turn your paper, figure out where your new point is, turn it back, and then plot that point. That's the easiest way to do this, okay? So if I do that, I'm going to end up with a point down here and down here. Okay, and remember, this is just a reflection. This is exactly what we've done in class numerous times. Sorry, excuse me, a rotation, not a reflection. Too many R words. Sorry about that. Okay. And again, I'm paying really special care to make sure that I'm not changing the graph in any way, right? Remember that I want these two shapes to be congruent. So I've done a 90-degree rotation, in this case counterclockwise. Okay, and now I've positioned my graph so that it looks like I can probably make a reflection to make this one fit. Okay, so I'm going to reflect the T over the, in this case, the y-axis, okay, because that's the line that I'm reflecting over, to make my newest version of the T fit onto the green T that I've been trying to kind of match up to. Okay, so let's kind of look at what we did. We started by translating near the origin. Then I did a rotation. Okay. Oh, excuse me. Actually, sorry. First, I skipped a step. I did a dilation, right? Because I had to make my shape match up with the kind of larger version that I was trying to match up to. Okay, then I rotated by 90 degrees. And the whole idea of that was to make this T that I, after the dilation, turn into a T that I could then move on to the other one. Okay, and then finally, I ended with a reflection over the y-axis. Okay, so it's a lot of different transformations all kind of being thrown together here. Okay, in addition to this reflection, okay, this last reflection that I did, instead, if I wanted to, I could have done this just as a translation. I could have just slid this point over to this point, and this point over to this point, and so on. Okay, so depending on the problem, you don't need to do the exact same steps that I do. Okay, my shape is a little bit different, and every shape's a little different. Okay, and realistically, there's lots of different ways to do this problem. Like, for example, if our graph had been big enough, we wouldn't have needed to translate near the origin, right? That would have been an unnecessary step. We could have just made the graph bigger and worked that way. Okay, so there's not just one right answer here. So that is one thing that can be a little bit difficult from my end to try and help you guys with this, because you could tackle it a lot of different ways. So honestly, if you just start messing around with these shapes and start doing the transformations, you'll probably get to a right answer eventually. It might not be the most efficient way, but you'll get there. Okay, the one thing that I want to strongly recommend to you guys is to do this first step, the translating it near the origin. Okay, and the reason why that's so important, again, is just because the graph is not big enough to fit your fully dilated shape, right? It's going to be way, way off the graph. Okay, so bring it closer to the origin first, and that will make your points a little bit smaller and make them easier to do. Okay, so one last thing, I want to go back to the actual problem that you guys are going to solve. So again, remember, the way that I figured out what to dilate by is I found some measurement that I could compare. So find something in these two arrows that you can know for sure is going to be the same, okay, or represent the same spot. So for example, I see across the arrow of the triangle, well, I can count that as 1, 2, 3, 4 boxes, okay, or 4 units long. Okay, so if I do that here, well, across the arrow, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my arrow went from 4 to 8. So you can probably figure out what your scale factor is, and then from there, you should be able to work this problem. Okay, so I'm not doing everything for you guys on this one, but again, my example should be able to help you, okay? So this is kind of putting together everything that we've done, and again, the only really new one here is dilations, and that one's not too bad, okay? Just again, remember, take your arrow, shift it down first before you start multiplying, because then otherwise it's going to end up off your graph, and you don't want that.